So I'm sorry about this. My smartboard's acting up and it's not really turning on. And so good, it's going to give me this notification. We'll try and work around it. Welcome to 5.2 part 2. And again, I'm sorry about this being a little bit later than I would have liked. Anyway, this is all about rationalizing the denominator. Um, so here's the deal. We can't really have a radical in the denominator. And so what we will do is something similar to we did with complex numbers and using the conjugate to get rid of that I on the bottom of the denominator or on the bottom of the fraction. And we'll get to do the same thing. If you remember then, we just multiplied by some sort of version of 1 because when you multiply by 1, nothing changes. So, for example, we take this, and it's going to be pretty simple. We're basically going to use whatever we see down here. Just like on the conjugate, if we saw like 2 plus I, we used 2 minus I. We didn't have to try and guess and check. We knew exactly what to use. Because square root of 3 times square root of 3, we could make square root of 9. The square root of 9 is 3. Or to be completely honest, if you have radical 3 and radical 3, they're going to be the pair under the radical that we take out. So we're going to multiply by this fraction here, root 3 over root 3, which is just 1. And the top becomes square root of 6. The bottom comes just 3. And even though they're the same value, this is more, I guess, mathematically acceptable. So we did this one over here where we learned in the last video we can actually piece everything together, and then we messed with our exponents here a little bit and then undid this. Oh man, it's in like the worst spot too. Then we took, after we got this and we split it up, well, the top simplified to just x. That was easy, and the bottom was still square root of 5y. Well, I'm just going to use square root of 5y because 5 and 5 make 25, y and y make y squared. And then when I square root that, it just becomes 5y. And then x times 5y on top just becomes, man, that's like the worst spot for this x square root 5y. Like those just go side by side and it just becomes 5y on bottom. And nothing cancels here because this is stuck under the radical. So we did the same thing here. Fraction inside is still not okay. We don't want fractions under here unless they can be square root really easy. So break it apart, multiply both by the bottom, and then we get our answer. Now this one was a little bit trickier because we had cube root. So we put it here, we put it all under one fraction, then simplified 4 over 6 to become 2 over 3. Then we split it back up. But we did something a little bit different. We still used 3x, but cube root means we need 3 of them. Well, I currently have 1 of them. So back here, square root, my invisible 2, means I need 2 5s for it to come out. Well, this cube root means I need 3x, 3x, and 3x before it can all come out. So that's why over here we use 3x all squared. Make sure that you don't just, well, I can't do it. Make sure you don't just square the x because the 3 needs to be squared also. We need 2 3s and 2 x's. But there's my fraction equals 1, and the top just becomes 2 times 3x squared. 3x squared, 3 squared is 9, x squared is x squared. 9x squared times 2 became this 18. And now that I have 3 versions of 3x on bottom, that's how I got 3x. This is where it was kind of like using the conjugate where we were talking about. Let me move this just a little bit so you can see. If we have a plus or minus here, very, very similar to the conjugate stuff with complex numbers. We're going to create a difference of squares. So my middle terms cancel out. So I don't even really have to worry about my middle terms. I'm going to use, since I see root 7 minus 2, I'm going to use root 7 plus 2. Because if I did, let me grab this. If I did that term there, that's 2 square root of 7, and that's negative 2 square root of 7, and they're going to cancel each other out. So I don't even have to worry about that. I go root 7 times root 7 is just going to be 7 because it'll be square root of 49, which is 7. And then negative 2 times 2 is negative 4. That just gives us 3 on bottom. Well, on top, we're just going to distribute, and I didn't even have to write anything here because when you distribute a 1, you just get the same thing. So we did the same thing here. 5 plus root 3. Well, now the root's in the end. Here the root was at the beginning. Doesn't matter. Just change the sign in the middle. Don't change anything in front or whatever. Just change the sign in the middle. Same thing, 5 times 5 is 25. Root 3 and root 3 make 3. But with this one being negative, we subtracted 3. We're distributing a 1 again, but it's 22 on bottom. Here was me showing kind of the example of the conjugate with I, and we were trying to figure out what was happening. I think, yeah, this is the last little bit. Okay, adding and subtracting, this was super easy. Basically, to add or subtract radical expressions, they must be like radicals. So like terms where it's like x squared and x squared go together, you're looking for cube root x and cube, like your radical has to be exactly the same, root 7, root 7. I got 4th root of 5 and the cube root of 5. This one doesn't work. That one just stays as is. But if the radicals are the same, we can combine them. Now, what if they don't start out the same? But when we factor everything out and pull some stuff out, you see how each one of these ended up leaving a 2? Well, you write them like that, and then the 18s actually cancel out. Factor this out. Divide by 2 and get 9. Divide by 3 and get 3. Well, the pair of 3s, this 3 times this 6 out here gave me 18. Divide by 2 and get 4. Divide by 2 and get 2. This 2 times this 4 gave me this 8. And divide by 2, divide by 2, divide by 2, divide by 3, divide by 3. 2 times 3 is 6. 6 times that negative 3 was negative 18. And then the radical 2's just stay as is. And we did the same thing here, except we did cube root, so we needed 3 of the same thing for it to come out. Whatever you factor out, scroll a little bit. Whatever you factor out multiplies, like the 2 times 3 gave me 6. The 3 times negative 4, negative 12. 2 times 2 is 4. 4 times an invisible 1 right there gave me 4. And then each one of these again left a 2. So that's why they all say cube root 2. And yeah.